Hi. So, first of all, I just want to thank you for taking the time out of your schedule to view this presentation. As it says at the bottom there, my name's Angela Dixon, and I'm one of the instruction librarians at Georgia State University's Dunwoody campus. In addition to my regular instruction duties, I'm also the STEM liaison librarian. My first degree is in electronics engineering. So prior to becoming a librarian, I worked as a broadcast engineer for Turner Broadcasting for maybe about 14 years. That was a small reason, a bit of the reason that I was enthusiastic about being assigned this role as a STEM librarian. In this presentation, however, I'd like to just share some of the approaches that I use to try to connect with the STEM students and the faculty during my first year in this role. Before I jump into it, though, I am in no way saying that all of the things here that I show you were a success. In fact, a couple of them were kind of flat out flops. But I just want to share some things that I tried, maybe give you some ideas or something you can pick from or kind of tweak, make it your own, or just avoid altogether. I just want to save you some time and effort, if possible. So, before we get started, I want to go ahead and give you some background into what I was trying to do. So, I'll try to make this part quick. That picture, before I say that, is of Dunwoody campus's library when it was busy. And I just threw that in there because I just kind of missed that period. Anyway, as you already know, Perimeter College and Georgia State University were consolidated by the Board of Regents maybe 5 or 6 years ago. Dunwoody campus is one of 5 campuses that makes up Perimeter. We function as maybe a 2-year associate's path for the students to experience the benefits of like a community college environment. So this is before, once they do that, they transfer to Atlanta and then earn their bachelor's degrees. Here at Perimeter, 60% of our students attend school part-time, and they do this while working and or supporting families. At Dunwoody campus specifically, each fall we average about 5,000 students. Now that is pre-COVID, so I'm speaking like fall 2019. We have around 27 different STEM courses each fall, and that's excluding multiple sessions and labs. However, the reality of all of that is that most of our STEM professors don't schedule library instruction sessions for their classes. And that makes sense because given that discipline, they're usually doing problem sets, problem exercises, and theory. But that reality kind of eliminated the way I normally meet the students and faculty. I'd meet them during instruction sessions. So I thought on it a little bit, and I decided to come up with my own means of trying to connect with this section of our student body. My purpose, or what the goal I hope to reach, was that I could establish myself and introducing myself as the STEM liaison librarian, of course, but I also wanted to increase the awareness of some of the STEM resources that I thought were being underused. Of course, books and ebooks and reserve items, but also like models, science models, anatomy models, chemistry models, and databases. We had really good databases that weren't being used at that point, as much as I thought they should have. So, moving on, let me show you what I did. So, what I thought about was I wanted to do programming and active displays, which is just table displays. So, the first thing I started out with is a Lego day. So, this was my first idea, and it was a softball approach to introducing myself as a STEM librarian using kind of STEM-related librarian programming. When I hosted Lego Day, we decided to call it Legopalooza. So over 86 students attended this event, and many of them stayed even past the time that the free pizza and snacks were gone, which surprised me. Actually stopped counting at 86 and just decided to let the students come in and build at that point. I'm also going to say that this was the Dunwoody event, but I'd also like to mention that I hosted 2 more Lego Day events, and those were at the Clarkston campus and Decatur campus. The Dunwoody edition was for STEM relation building on my part. I hosted the other 2 just as a general perimeter library outreach programming. The total count for all 3 of those events was a little bit over 175 students, so I think I'm going to count that one as a win. Addition to that, the impact I would count as a win because it influenced downtown campus to also consider Lego Day. They had not had one before. We had ours in October, and they hosted one in December. Did really well also, but that idea came after ours, so I think that's a win. The picture there is one of Instagram and the students downtown playing with their sets. So moving on. The next thing I did was a biology lab, like a mini lab. What this was it was mini instruction. It only met for 15 minutes. So we sold it. I don't need to have the whole 50 to 75 minutes. I can give you what you need in this 15 minutes. How this came about was a biology instructor, a new one, mentioned to us in passing that his students always seem to have difficulty writing acceptable lab reports. Basically, he was disappointed in the quality of lab that the students were submitting to him. So my supervisor, offered my assistance as the STEM librarian. So no, I did not volunteer for this assignment. However, it ended up being kind of a great experience because it was a confidence booster for me. It gave me more confidence in approaching the STEM faculty and being able to explain what value we could add, what we could give them to the class to kind of supplement whatever they needed. What happened? I came into his labs once each semester, but it was each of his labs, and it was only for a 15-minute period, as I said, but I gave them an overview of library resources, and these are the resources that would serve as sources for the lab write-up. He wanted them to have additional sources in addition to the lab book and the textbook. He wanted outside articles that related to their lab. I also took the time to explain his instructions in an easier to read layout, easier to understand. So on the left hand side of this page is his assignment to the students. That's what the students saw at first. On the right hand side is just a LibGuide. That's how I kind of ticked through the overview of everything I was showing them, and it also gave them a link, a reference to come back to later, something they could keep referring to even though they wouldn't be meeting with me regularly. So from his sheet there, I pulled out the most important information there. I also linked his actual sheet so they could compare one for one, and then I gave a visual explanation of what he has there in his text with the layout there. It's explained in text, but I just wanted to show for the visual learners how their lab should be laid out. This was just a screenshot of the first part of the LibGuide. Additionally, I showed them or listed databases that were specific to that assignment, and I explained like basic things, what we offer at the library and what the difference is between popular, scholarly, or peer-reviewed articles. Just a quick overview of things. But most of the students came to me afterwards. So this was a success in that I made a connection with a professor, but I also made some connections with the students so that they would recognize that I was there to help them also. The next thing that I did was tables. I started doing display tables. And I wanted them to be interactive. So these topics I chose on my own. This wasn't related to anything. It's just something I thought, oh, gee, I think that's interesting. That's what I'll do. I picked a corner of the library. I call it the STEM corner. set up a long table and put up these displays. And this first one, what I was going for was all of the models there. I bought all of the models there except for the cat. There's a purpose in me telling that, and I'll explain later. But I wanted the models to be something that had removable parts, things again that they could interact with, take them apart, leave them if they couldn't get it back together. But you know, for the most part, they always put it back together. So we had the brain there, the teeth. There's a torso too. I think that was it, and of course the cat. I also included these X-rays because they had fractures, and like I think the skull had a bullet in it. And the students, that actually drew a lot of attention because they would hold it up to the window to see where, you know, the fracture was or what the incident was. And I chose that corner because of the lighting, so I thought that was pretty, you know, pretty awesome. What else about that? So I included the books from the collection, but I also gave an example of the ebook. So that's what the squares in the bottom right hand corner, little blocks, that's just a visual representation of the ebooks that they had to choose from. And I kind of switched up whatever we had on the table, maybe every 2 or 3 days to keep it fresh, just to let them know what we had. After we got that table up, I just wanted the students to have some buy-in. I wanted them to feel like that was their own, or they were a portion of this. So I walked over to the life sciences hallway, walked through it, and I ran into a professor who invited me in. She was very friendly, and I just asked her if she would be interested in adding anything to the display and what I was trying to do with this display, this monthly display. She was enthusiastic, and she actually loaned me the class poster. That's the one on the tripod there. And she gave me 2 trifold student-created assignments. That's like the big brain there with the student's name on it. And that kind of got some of her students to come in to look at the exhibits because their work is included also. The posters were donated by Professor Patricia Moat. That being said, this established an ongoing relationship with her. So I deemed this one a success because it provided faculty outreach for me and collaboration. The next thing was a table on ecosystems. Again, I'm going to stress, I purchased everything that is on the table, everything live, the snails, the shrimp, everything there, the ant forms. But Patricia Moat, or Professor Moat, actually gave me the poster again, and then she gave me 2 small folder posters, experiments from 2 of her other students, and they're like behind the ant form there. The library team, surprisingly, voluntarily assumed the daily feeding and care of the live displays or the editions. Now this was a good thing because as you see the ant form there, that's actually the second ant form. The very first one, I'm not going to say I killed it, but all of the ants died before I even finished putting the table up. So this was all a learning experience. And circulation staff actually started doing research with me into some of the things I had on the table and figuring out what's best for it. Like they figured out that you can't put that gel in the ant form in front of direct light, gets too hot, kills them, adds too much moisture. These are just things I learned from everything. Moving on, the next thing that I did was a Black History display. Now, I know what you're thinking because I thought the same thing. But I just didn't want to do another Black History display. It was just, oh, here's some Black authors, books, and here's some CDs or whatever. I wanted to do something more. I wanted to do something that had a STEM connection. So the intent with this was I had, what do you call these? I wanted to show the STEM relevance to the use of everyday objects that were also created by African Americans. I chose items that were common but wouldn't be common knowledge for the average student. So I chose things like a beer keg faucet or tap, guitar, ice cream scoop, working traffic light, and that garnered a bunch of attention also. So that one's a success just because I enjoy the research. The students also came over to look at it, but there was a lot going on with this. The next thing I did, the next table, was simple machines. Simple machines, again, I set out thinking I wanted it to be even more active learning. I read somewhere that if you keep the interest of a STEM student in that discipline, the excitement of active learning has a chance of having a higher retention for those students in that field. But that being said, I actually put this table up the first week of March. As you remember, the second week is when all of the quarantine things begin to happen, so I was unable to see the full display or the full potential of this display. I tried to make it more interactive. I actually built the catapult and everything there, everything on the table, but I actually wanted the students to check those things out and actually, experiment with them. That was the intent. Did not go as well as I had planned, but. And lastly, I did TI81 or 84 workshops. These workshops were probably my most successful event or programming. So all of the campus libraries loan these calculators out to students. I think it's for a week at a time. From time to time, though, students would come to the circulation desk and the reference desk to ask for help in using them. So I thought about it, and I proposed an idea to my team. I said I remembered when I was struggling with the operation of my TI81 in all of my engineering classes. We just had to teach ourselves with that thing. And I thought, wouldn't it be great for them to actually have someone teach them? And yes, given that model number that I just rattled off, I should have tacked back in the day to that statement, but that model number tells you it was earlier. The TI84 workshop was, again, the most successful, and I'm gauging success in terms of a few things. First, the number of students that attended an academic workshop. You know how difficult it can be to get students sometimes to attend something that's actually fun. But this was an academic workshop that had really good showings, and they stayed through and they asked about it afterwards. So that's excellent. There's also, in this one, I finally had direct relevance to the student coursework, something they could use immediately. And finally, I'm judging success on the impact it had on influencing other departments and campuses to consider presenting similar workshops. So in this case, I had the math tutor, the head of the math tutoring center, teach the classes. He has great energy and so much enthusiasm that made the students even more engaged. So very happy about that. We ended up having two. The tutoring center afterwards, speaking of impact again, actually hosted a live online workshop after witnessing the student interest in these one-on-one ones. Our second largest campus, Clarkston, after ours, hosted a twice-a-week calculator workshop. So, and then finally, on the right-hand side there, the Instagram shot there was a shot of same guy teaching, but it's showing the student asking from downtown when they were going to have the same down in Atlanta. So that shows that we were filling a need. We identified and filled the need. So I'm counting that success on that row 2. The bottom left-hand side are just flyers. I just kind of wanted to show how I was pulling out all the stops to try to draw students in again. Still pushing STEM. I designed this little flyer. I cut them out, and I actually placed those in the calculator cases so that when we loaned them out, that the students would have a reminder about the event. So now, with all of that, I want to tell you about some of the lessons I learned and some of the things I didn't consider, and yeah, some things I probably do differently going forward. So what did I learn? My lessons, mostly they were challenges. So the most important thing, the thing that stands out, is that cost of supplies, that's why I kept bringing it up earlier, was a significant factor. I purchased everything, like I said, except the cat for those displays. So I should have given a little bit more thought to how to finance the goals I had in my head. Additionally, I did not realize how expensive Legos are. Those things are really expensive. I had about 5,000 pieces, a little over 5,000 pieces, for each event. So, yeah, pretty expensive. Additionally, Legos are a rabbit hole because I hadn't used them prior to this. But I became kind of obsessive about it, obsessed. And that's what that signifies at the bottom there. I actually built that car, and I'm proud of it, so I thought I'd stick it on the slide, and I added the light kit to it. That spread out as the parts before it was built. That's just to say how obsessed I became with that for that period. So that was a lesson learned, not to get too engrossed into something that you're not thinking outside of what purpose it can serve later. Additionally, I've already told you about the ant forms. The first one died. The second one made it. But one benefit of that was I met another professor who actually specializes in the study of ants. And she came over and kind of gave me a few ideas of what was going on. And she looked at the gel and was going to take it to her group. Her study group, the other people that also study ants with her, and talk about it. So that was a win. The bottom corner that's what my office looked like most of the time. I didn't factor in, I didn't consider, in addition to my regular instruction duties and reference, chat, regular reference at the desk, and just meeting students outside that in the library, how much time all of these things would take. I built every model. I built all the bottles. Actually, of ecosystems. I actually walked down to a pond and dipped out the sludge and water and let them sit in my office and kind of go through the cycle. So that was a lot of time, but off the clock and on the clock. It was just a lot of time building things. Also, I think what I would consider going forward would be that I would connect the content to subjects the students are actually covering in class. I would ask professors, instructors, if maybe I could see their lesson plan or syllabus just to match up pound for pound or subject for subject, tick for tick, whatever they are studying with whatever resources that we have in. Going forward, that's what I would do. I would also want more student interaction to kind of be able to ascertain the educational value of my displays or whatever I was putting forth. Maybe add QR codes. I'm still figuring that out. So again, if you have any thoughts on that one, feel free to drop me an email because I'm still trying to figure this out as we go. How to kind of quantify the value of these. And lastly, another money and just basic horror thing that happened was every morning that I came in, I bought about 2 to 3 cherry shrimp for each bottle on that display. Cherry shrimp ranged about $7 a piece. Every morning that I would come in, I'd notice that I'd have one less shrimp, and I thought the students were taking them out. I just couldn't figure out what was going on there. I was like, is this a prank? What is it? So it turns out I did not know there was such a thing as assassin snails. I sped this up so you could see because I didn't see it till later. I thought snails were so slow that they wouldn't possibly catch my shrimp. But that's what was happening. Each morning I came in, the snails had eaten another one of the shrimp. So again, we're talking knowledge and money. Learned some things, but in addition, maybe I should have stayed in my lane as far as choosing the setup. And lastly, I'll give you a few tips. Tips from what I think I've learned from it, and see if you can use it, take it or leave it. I think the first thing I would consider is always think of the students first. The material should always tie in with whatever the students are actually learning. I've already said our students, 60% of them work outside of this, so their time is very sensitive, and it should, any subjects that you hand them should tie in so they can learn directly and take that going forward. I'd say enthusiasm is okay. Don't be afraid to kind of geek out, and that's what I was doing. But don't be ashamed. I think when your excitement makes the students even more excited about it. And again, that builds with retention and just excitement over the subject itself. Ask for help. I didn't learn until later when the co-workers volunteered that they would even be interested in such things. So don't be afraid to ask for help. I spent way too much time on my own building models and cars, and I just spent too much time on that, and I could have had help with that. So don't be afraid to ask for help. Additionally, I think with the admin coordinators, send them an email and meet them in person, just to introduce yourself as their liaison librarian. I say that because admin coordinators usually know a lot about what's going on behind the scenes, and they can introduce you to the right people, tell you the steps of the processes. I actually met one who gave me STEM reserve books, textbooks that we added to the collection. So these are the things that add value. At the end of the semester, I would say send thank you gifts, small thank you gifts. I'm not saying anything grand. I actually bought the Georgia State cups and put candy in it and just wrapped it up. I gave these to, of course, the admin who helped me a ton, and I also gave it to Professor Mope, who contributed all the material, the posters for my tables, display tables, and I also gave one each to all the workshop guest speakers and teachers. I had a few more, but they weren't STEM related, and that's why. But I think the gifts let them know that I am grateful that they came and they helped, they collaborated, but I also want them to remember me for future collaboration, to know that it'll be worth their time and they will be appreciated. And lastly, I just want to show you my sources, and these are my references. Again, thank you. Thank you very much for taking the time to watch this presentation, and I hope you have a great day. Bye-bye.